Hey there, class. Mrs. Matheson here. We are in Unit 6. We're going to cover Notes 4. We're actually going to be doing Day 1 today in the notes. Our objective is to understand how the properties of similar right triangles allow the trigonometric ratios to be defined and determined the sine, cosine, and tangent of an acute angle in a right triangle. Whew, that's got a lot going on there. Really big thing we're going to be talking about is sine, cosine, and tangent. And we're going to use those. Okay, so just so you guys know, trigonometry comes from two Greek terms, trigon and metron. Trigon means triangle, metron means measure. So really what we're doing is we're talking about the measure of triangles. So we have some symbols, we have some words we're going to talk about. Sine is our opposite over our hypotenuse. And when we talk about this, we're referring to sine of A. So that A represents this angle. So sine is our opposite, which is little a, over our hypotenuse, which is our little c. Hypotenuse is always across from the right angle. Okay, if we talk about the sine of B, that's opposite from angle B. So opposite from angle B is our little b, and our hypotenuse is C again. We do not do the sine from angle C because the sine is opposite over hypotenuse. The opposite is the hypotenuse, so therefore we don't have a sine. Okay. Then let's go ahead and talk about cosine. Cosine is adjacent over hypotenuse. So if we're back to angle A, adjacent is the one next to it. So that gives us B over our hypotenuse, which is C. Let's talk about it in relationship to B. Its adjacent, again, is right next to it. So A over the hypotenuse of C. And then we have tangent. Tangent deals with opposite over adjacent. So in A, our opposite is our A, and our adjacent is our B. Now let's refer to the tangent of B. The opposite is little b, and the adjacent is the little a. All right, and actually, I want you guys to jot down this. So, ka, toa. So, ka, toa. This is a little mnemonic device to help us remember what sine, cosine, tangent all mean. Sine is the opposite over the hypotenuse, just like we have here. Ka is cosine, which is adjacent over hypotenuse. See how that's working out? And then toa is our tangent, which is opposite over adjacent. It's a little mnemonic device to help us out. Okay, so we're just going to get to practice finding trig ratios and getting familiar with doing opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse. All right, express each trig ratio as a fraction and as a decimal to the nearest hundredth. So hundredth is 2 decimal places. Okay, so we're going to talk about the sine of j for a. So I'm just going to jot down so ka toa, because I don't have it on my page. You do. So sine, so that's going to be telling me right here, I'm doing opposite of j. So opposite of j is my 5. Over my hypotenuse, which is 13. Go ahead, we want to make this into a decimal. So we're going to divide 5 divided by 13. And we get 0.38 when we have rounded to 2 decimal places for our hundredth. Okay, let's do cosine of that j. Cosine, we're looking here at adjacent over hypotenuse. So the one that's next to j is our 12 over our hypotenuse of 13. Go ahead and divide those two on your calculator. Round to the nearest hundredth, so only 2 decimal places. And we get 0.92. All right, tangent is going to give us the opposite. Ooh, that opposite we said was 5 over our adjacent, which we just talked about, is 12. So 5 divided by 12 gives us 0.42. 0.42. Okay, next, it's asking you to do it in relationship to angle K. So here's our angle K. I want you to pause the video here and come up with those measurements for me. You give it to me as a fraction, give it to me as a decimal. Okay, so you should have paused it and we're going to come back here. Now we're going to look at them with some square roots. Square roots aren't scary, so we're just going to tackle these one by one. So it says sine of L, cosine of L, and tangent of L. So here's our reference point. Again, you might want to jot this on the top of your paper so you don't have to keep flipping back and front. So SOHCAHTOA. The sine of L. So we're looking opposite over hypotenuse. Opposite of L is our, oops, let me fill this in. 2 square root of 3 over our hypotenuse, which is our 2 square root of 15. Okay, and then let's just divide those and give them as decimal places. 2 square root of 3 divided by 2 square root of 15. If you're typing it all in one, make sure you're putting some parentheses in. All right, 0.447. So let's round that to 0.45. Okay, now we're going to do the cosine. Cosine is adjacent over hypotenuse. So cosine of L, adjacent over our hypotenuse. Again, if you're going to type it in one step, put it in parentheses. Okay, I have 0.894. So 94 tells us we're going to keep it as the 9. All right, last we have tangent of L. Tangent is opposite, so we said that's our 2 square root of 3 over adjacent, 4 square root of 3. Hey, we just finished talking about with 30, 60, 90 triangles and 45, 45, 90 triangles. If you have a square root in the top and the bottom, it cancels. So we have 2 over 4, which gives us 0.5. Okay, so now we have an understanding just talking about where we can get sine, cosine, and tangent from. Let's actually put it into use. A fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So we're trying to find y. That's this height of how much it was raised. Okay, so we need to decide, do we have sine? So do we have cosine? Oops. I messed up there. There we go. Ka or TOA. So we are always in reference to our angle. So from our angle, that y is our opposite, and that 5 is our hypotenuse. So which one deals with opposite and hypotenuse? Good. Sine does. So we have sine. Now instead of using like L or these references to the angles with the J's and the K's, we're actually going to put in that measurement of 7 equals our opposite over our hypotenuse. Okay, we're going to solve for our y, so we need to get rid of divide by 5. We do that by timesing both sides by 5. So we have 5 times the sine of 7. Now here's the kicker. You absolutely need a calculator for this, and your iPads aren't going to be considered sufficient. So you need to get yourself a scientific calculator, and we want to make sure it's in degrees. If you don't know how to make sure it's in degrees, look at the bottom of your screen and it'll say DEG or RAD. If it says RAD, reset your calculator. If it says DEG, you're set up just fine. So take and type in 5 parentheses sine 7 close parentheses and see what you get. All right, we will put that answer in our quiz and we'll talk to you guys later.